Hello, in this video we're going to look at the use of a quadratic formula to solve a trigonometric equation. So here we have this example, sine squared of x equals -2 plus 3 cosine x. Now, we'll have to use an identity first before we can even recognize that we're going to need the quadratic formula. So we have two different functions, cosine x and then sine x, and then the sine is squared. So we know from the identities that sine squared is the same thing as 1 minus cosine squared. So we're going to go ahead and substitute 1 minus cosine squared in the place of sine squared, and then just rewrite everything else. Now, what I notice is I have all one function now. They're all cosines, and I have a second power, a first power, and then some constants. So I probably have a trinomial. So I'm going to go ahead and move everything to one side equal to 0, and I want the leading term to be positive. So I'm going to add cosine squared and subtract 1 from both sides, right? So I'm going to have cosine squared plus 3 cosine x, and then this becomes a -1 added to a -2 gives me a -3, right? So here we are. Now if I let, for example, t be cosine x, what I can see is I have 0 equal to t squared plus 3t minus 3. And that's a little easier maybe to recognize. And when you go to try to factor, you're like, well, okay, let's try this. T times t, and obviously -3 only has the factors 1 and 3, so let's try this. And since this is positive, we probably want the 3 to be positive and this to be negative. When you keep trying things, you're like, okay, t squared minus 3, now the insides, or the middles, so I'll have plus 3t, and then minus t will give me plus 2t, so that doesn't work. Like, nope. Let's try another combination, t plus 3, plus 1 maybe. T, let's see, minus 3. I'm just trying here. So again, you get your t squared, but when you try this, you have plus t and then minus 3t, so it gets even worse. It's now -2t, and you're like, you know, if you try all the combinations, you're like, I don't think this is factorable. So that's when you go to the quadratic formula. So let me rewrite this. T squared plus 3t minus 3 equals 0. So we're going to apply the quadratic formula to that. And so we're going to have a is equal to 1, because it's 1t squared. B is equal to 3. And c is equal to -3. All right, so now you're going to plug this into x equals -b plus or minus square root of b squared minus 4ac all over 2a. And now we're going to plug in. So we'll have -3b plus or minus square root of b squared, so 3 squared, minus 4 times a, which is 1, times c, which is -3, right? All over 2 times a, which is 1. All right, so now we start. I like to simplify what's under here. So you have -3 plus or minus square root of. Now, all over 2. Let me get that out of the way. So we have 9, right? 9, and then minus a minus is going to be plus, right? So when I multiply all these out, I have a negative times a negative times a positive, so it's going to end up being positive. 12, right? So now, 9 plus 12 is going to give me square root of 21. All over 2. We're now down to our two options. Now we can actually write either x equals -3 plus square root of 21 over 2, or x equals -3 minus square root of 21 over 2, right? So those are our two possibilities. We've actually solved for x, but remember, we're really, I guess I could have really said t. That probably would have been a little bit better. So if I had instead let this be x squared plus 3x minus 3 equals 0, we just solve for x, so I can call it t or call it x, but this is it. But remember, we let t or x be cosine x, so really what we solve for, let me go ahead and just kind of rewrite this, so it's hopefully not confusing. We really solve for t, right? So now I can say that since t was cosine x, right, we let t be cosine x, then we can say cosine x is these things. So I can now say cosine x is -3 plus square root of 21 over 2, or cosine x is -3 minus square root of 21 over 2. Okay. And so now let's go ahead and get numbers for these. If we go ahead and put in your calculator -3 plus square root of 21, be sure to put parentheses and then divide by 2. We're going to get cosine x equals, let's see here, 0.7913. And here again, if we put in -3 minus square root of 21, all in parentheses, and then divide by 2, we're going to get cosine x equals -3.7913. Now we know that the cosine of an angle never exceeds 1 or is less than -1, so this is not possible, right? So we're really only dealing here. So now we can say, oh, okay, I'm looking for that angle for which the x-coordinate is a length of positive 0.7913, right? So we'll let the calculator find our first solution by finding the inverse cosine. And then we'll get that x is 0.6579 radians, of course. And so what we're saying is, when you rotate over here 0.6579 radians, let's say you're here, the x-coordinate is a length of 0.7913. So here, x equals positive 0.7913. And then, of course, you're asking the question, well, where else is the x positive? Well, it would be here in quadrant 4, right? This angle. And this angle would be negative 0.6579. It's the same rotation, but in the negative direction. And this is fine. However, most books usually like to make that a number between 0 and 2 pi. So you can just add 2 pi to it. So if I just say negative 0.6579 plus 2 pi, I'll get 5.6253. Most books will get you that. So now I have both angles, and I want to go ahead and get the generators, what I call the generators. So we basically have the angles you're looking for, x is 0.6579 plus 2k pi, and then x is 5.6253 plus 2k pi. But again, I could have written negative 0.6579 plus 2k pi. All right? And of course, here k is an integer. All right, so if you want specific values, just put in integer values of k into each one of these. All right, thanks so much for listening.